So to integrate this one, I'm going to use trig substitution, where I'll say let x be equal to 3 sine theta. The reason why I've let my x to be equal to 3 sine theta is what I want to come up with a way of producing 1 minus sine squared theta, sine squared theta inside the root. So you check whenever you want to use this trig substitution, you check what kind of value you have here as your constant. So in my case, I have a 9, meaning that for me to factor out a 9 into a 1, I'm going to need a 3 squared. So for you to check, whenever you want to rewrite, if you have a 9 here, look for a number that you can multiply by 2 or that you can square to get a 9. If you have a 4, you square a 2 to get a 4. So that when you factor out this 9 here, you are going to remain with a 1 here and a 1 here. So in my case, it's a 9. That's why I've used the 3. So if you have a 4, you use 2. If you have a 16, you use 4. If you have you just check which number you can square to get to that number. So here I'm going to differentiate this. I'll get dx, which is equal to 3 cos theta. Replacing in my integral, I have the integral of, where there is x squared, I'm going to put 3 sine theta. So I'll have 3 sine theta squared, then everything over the square root of 9 minus 3 sine theta squared. Then where there is dx, I'm going to put this d theta. So I'll multiply this by 3 cos theta d theta. Simplifying this, I'm going to get the integral of 9 sine squared theta multiplied by 3 cos theta d theta. Then everything I'll divide it by the root of the square root of 9 minus 9 sine squared theta. With this I can simplify, meaning I'll get the integral of 9 sine squared theta multiplied by 3 cos theta d theta, then everything over, so dividing everything by, I'm going to factor out a 9 here. Since I have a 9 and a 9 here, I can factor it out. But whenever you're factoring a number outside the root, it's supposed to carry a root. So if you're factoring a 9 outside the root, it's going to be square root of 9. If you're factoring a 4 out of the root, it's going to be square root of 4. So in my case, I have a 9, so it's going to be square root of 9 multiplied by 1 minus sine squared theta. Then simplifying this, I'm going to have the integral of 9 sine squared theta multiplied by 3 cos theta d theta, then everything over, I'm going to divide it by, there's root of 9, it's a 3, then square root of 1 minus sine squared theta is an identity. So this 1 minus sine squared theta is equals to cos squared theta. So I can replace by cos squared theta. With this, I can say my integral is going to be this 3 and this 3 will cancel out. Then this 9 here, I can take it outside the integral. So I'll have a 9 multiply 9, then integral of sine squared theta cos theta d theta, then everything over square root of cos squared theta is cos theta. This cos theta and this cos theta will cancel out, meaning that I'm going to remain with 9 the integral of sine squared theta d theta. Integrating this sine squared theta, we can simplify it by using an identity where we know that sine squared theta is equal to 1 minus cos 2 theta, then everything over 2. So I can replace this identity into my integral. I will have 9 then integral of 1 minus cos 2 theta, then everything over 2 d theta. Factoring out the 2, I'm going to have 9 over 2, then integral of 1 minus cos 2 theta d theta. Integrating this now becomes easy because I'm just going to apply the normal integration, where I will say a 9 here over 2, then open the integral of 1 with respect to theta is simply theta, minus the integral of cos is sine. Differentiation of sine is cos. So here the integral of cos will be sine 2 theta. Then we're going to differentiate the angle. So the angle is 2 theta. Differentiating it with respect to theta is going to give us a 2. So when differentiating, we normally multiply that inside differentiation with the whole function. But since here we are integrating, we are going to divide the inside differentiation by the whole function. So the inside differentiation of the angle is 2. So we're going to say over 2. Then plus c. Simplifying here, we're going to have 9 over 2 theta minus 9 over 2 times 2. It's giving us a 4 sine 2 theta plus c. If you have done this, then you have your integral.